Today we're going to talk about using integrals to find the area of different functions. So let's say I have two functions. Let's call that f of x and call that g of x. If I wanted the area bounded by those two curves, what we're going to do is find the integral of the top minus the bottom. So in this case, it would be the integral from a to b of f of x minus g of x. Okay, if we have a graph that changes which one is on the top, so here we want this area and this area, we'd have to break it up into two different integrals. So it'd be the integral here of top minus the bottom. So that would be the integral from a to c. The top one here is g. The bottom is f. And then we would add that to the integral here. So from c to b of top minus bottom is going to be f of x minus g of x. Sometimes it's going to make more sense, rather than looking at things vertically here, we'd look at things horizontally. So if that's the case, we would write the equations in terms of y. And we do the integral of right minus left. Okay, so let's say this is g of y, this is f of y. So this is going to be the integral from d to c of g of y minus f of y dy. Okay, so we're going to find the area of the region bound by the graphs of f of x equals sine of x and cosine of x, and the lines x equals pi over 2 and x equals 5 pi over 4. So let's go ahead and graph. Okay, so we'll go ahead and graph a sine. And we'll graph a cosine. Okay, and then we have the lines x equals pi over 2 and x equals 5 pi over 4 is actually going to be this intersection. So this is the area that we are trying to find. So this one, our integral from pi over 2 to 5 pi over 4 of the top function minus the bottom function. So the top in this case is going to be the sine curve minus the cosine curve. Now, in your homework, you can just simply type this into your calculator for today's, because what we're focused on is can you set up the integrals. But in the future, what you'd have to do is actually do the antiderivative. So that's what we'll do here. So integral of sine is a negative cosine of x. Integral of cosine is sine. And we're evaluating this 5 pi over 4 and pi over 2. So this is going to be negative cosine 5 pi over 4 minus sine 5 pi over 4 cosine pi over 2 minus sine pi over 2. So at 5 pi over 4, both sine and cosine are negative. So since these are both negative, this is going to be positive root 2 over 2 plus root 2 over 2 minus cosine of pi over 2 is 0. Sine of pi over 2 is 1. So we're going to add 1 here. So this is going to be root 2 plus 1. Okay, for the next one, we're going to find the total area of the regions enclosed by the graphs of the line 2x and the cubic function 6x minus x cubed. So I'm going to go ahead and use the calculator to help us here. So we'll just graph it on a standard window. There's our line. And there's our function. So we're interested in this area and this area. So we have this area and this area. So what we need to do is figure out what these points are, and we can use the calculator to find those intersections. You will find that the intersections, this one here is -2, this one is +2. So this is one where it switches which graph is on top. So this is going to be the integral from -2 to 0. The top is 2x. The bottom is 6x minus x cubed. And we'll add that to this one, which is going to be the integral from 0 to 2. The top one there is the 6x minus x cubed minus 2x dx. Now this graph is symmetric, so this area is going to equal this area. So you could just take one of these and double it. So I could just do 2 times the integral from 0 to 2 of 6x minus x cubed minus 2x, or double the other one. To 2, so this 6x minus 2x, we're going to have 4x minus x cubed. So we will integrate that. Okay, so we're going to evaluate this at 2. So this is going to be 2 times 2 squared minus 1/4 2 to the 4th minus 0. If I plug in 0, we're just going to have 0. Okay, so here we're going to have 2 times 2 squared, so that's 8 times 2 is 16. 2, that'll be 1/2 times 2 to the 4th. 2 to the 4th is 16 divided by 2 would be 8. So this integral is 8. Find the area enclosed by the curve y equals the square root of x, the tangent to the curve at 16, and the y-axis. Okay, so if we're graphing the square root of 16, or graphing the square root of x, going to be a curve, looks like that. We're going to draw the tangent line at this point. So that's going to look something like that if it actually touched. And the y-axis. So we have this area here. So this is the square root of x, and we need to find the equation of that tangent line at 16. So we know the point there is 16, 4. The slope is going to be 1 over 2 root x. So at 16, that's going to be 1 over 2 root 16. So 1 over 2 times 4, or 1/8. So we're going to have y minus 4 equals 1/8 x minus 16. So y equals 1/8 x plus 2. So now we'll set up our integral. So we're going to have the integral from 0 to 16. The top is going to be 1/8 x plus 2 minus the bottom is square root of x. Okay, and you can do all the anti-differentiation, or you can plug it into your calculator. If you do that, you're going to get 16 thirds. This would be one that you should be able to do by hand, but for the sake of time and the interest of getting the setup correct, you can just type it in the calculator for now. Okay, next we're going to find the area of the region enclosed by y squared equals 4x and y equals 2x minus 4. And we're going to do this in two ways. We're going to integrate with respect to x, and we're going to integrate with respect to y. So we'll go ahead and graph this. Okay, so first I'll graph the line because that's easy. So we have the line 2x minus 4, 1, 2, 3, 4. Okay, this other one, we have y squared equals 4x. So that means y is equal to plus or minus the square root of 4x, or plus or minus 2 root x. Okay, so at 0, we're at 0. At 1, we're going to be at 2. At negative and negative 2. And then the other intersection point is going to be at 4, 4. There you go. So the first way we're going to do this is with integrating with respect to x. So my cross sections are going to look like that. There's a switch here. So from here, it's going to be the 2 root x on top and a negative 2 root x on the bottom. But then at this point here, at 1, and 1 is going to be at negative 2, it switches, so then it's the top is the 2 root x and the bottom is the line. So we're going to have to split this up into two integrals, and we're doing this with respect to x. So this is going to be the integral from 0 to 1 of the top is 2 root x minus the bottom is negative 2 root x. And then we're going to add that to the integral for the rest, which is going to be the integral from 1 to 4, because that's that intersection. The top is 2 root x. The bottom is going to be the line, so 2x minus 4. Okay, so I'll clean it up a little bit, and then we'll just use the calculator. So this is going to be 4 root x 2 root x minus 2x plus 4 dx. So if we plug this in the calculator, you get 9. The catch here is, if I go the other direction, if I make my cross sections horizontal, I don't have to write it as 2 different integrals, because this one is always going to be the right bound, the green one is always going to be the left bound. But I need to write the equations in terms of y to do that. So we're going to take each of the equations, this will be y squared equals 4x, which means x is going to equal y squared over 4. We have y equals 2x minus 4, so y plus 4 equals 2x. So x is equal to y plus 4 over 2. So those are the two equations that we're going to use in our integral. So with respect to y, it's going to be the integral. We're going to use the y values this time. So we're going from a y value of -2 up to a y value of 4. Then it's going to be the right minus the left. So the right is the line in terms of y is going to be y plus 4 over 2 minus the parabola. And this is going to be dy. So everything is in terms of y. The bounds are coming from the y values of those intersections, and then the equations in terms of y. When you type it in the calculator, you can just use x instead of y. But you'll get 9 again. Okay, we're going to find the area enclosed by sine pi x over 2 and y equals x. So let's use the calculator to help draw the graph. And you could graph it by hand as well. Okay. All right, so we're going to zoom in to see what we want to actually see. So we're looking for these little parts of the graph, and we'll find those areas. So the intersection points are going to be at 1, 1, and -1, -1. So this is another one that either we'd have to break it up into 2 integrals or just double one of the integrals. So that's what I'm going to do. So it saves us a little bit of work. So we're going to double the integral from 0 to 1. The top there is the sine pi x over 2. The bottom is x. Type that in our calculator, and we get 0.273. We're going to find a vertical line, x equals k, that divides the area enclosed by x equals y squared, which is just x squared equals y. And x equals 2, y equals 0 into 2 equal parts. Okay, so y equals x squared. X equals 2 is our vertical line there. And we're trying to find a k that makes it so that this area is equal to this area. So we're going to set up an equation involving integrals. So we're going to have the integral from 0 to k of x squared minus, sorry, set that equal to the integral from k to 2 of x squared. Okay, so this is going to be 1/3 x cubed evaluated from 0 to k. This is going to be 1/3 x cubed evaluated from k to 2. So this will be 1/3 k cubed. This is going to be 1/3 2 cubed minus 1/3 k cubed. So I'll add that over. So we have 2/3 k cubed equals 8/3. Okay, so multiply by the reciprocal there, so this is going to be 4. So k cubed equals 4, which means the k that's going to split this into 2 equal places will be the cubed root of 4. Alright, so we're going to find the positive value of k such that the area of the region enclosed by the graphs of y equals k cosine of x and the graph of kx squared is 2. So again, we're going to have an equation involving integrals. So I don't know what the k is, so I'm just going to kind of draw a general graph. K cosine is going to look something like that. And then k squared is just going to be a parabola. So we want this area here to be 2. So I need to find the intersection points. So that's going to be where k cosine of x is equal to kx squared. Well, the k's don't actually matter because I can divide by k. So I'm looking for where cosine of x is equal to x squared. So I'm going to use my calculator to find that. Okay, so second calc, intersection. And we want first curve, second curve, guess. So our intersection is 0.82413 and 0.67, but we don't care about that. The value that makes these equal is x equals 0.824. I'll just go there. Okay, so that's this value. We want this whole area to be 2. So I'm going to say 2 times the integral from 0 to 0.824, and I'm doubling it. I could go from negative 0.84 to 0.84, but this seems easier. The top is going to be k cosine x minus the bottom is kx squared. We want that to equal 2. Well, this k is just a constant, so I can pull that out. Okay, I can divide by 2, and I'll go ahead and use the calculator to evaluate this integral, and you'll get that it's 0.547. So then just divide by that, so the k would be 1.827, would make those two, make this area equal to 2. Okay, so it's the area between x equals y squared minus 4 and the y-axis. So this is going to be a sideways parabola moved back 4, because if we plug in a y value of 0, we have an x of negative 4. When x is 0, my y's are going to be at 2 and negative 2, because those are the two things that will make that 0. So I have a graph that looks like this. So we want this area, and you can do this in 2 different ways. You can break this up into 2 equations, a top equation and a bottom equation, and do that, or we can make our cross sections horizontal. So if we do that, our integral is going to go from negative 2 to 2. and it's going to be right minus left. So in this case, the right is 0, and the left is y squared minus 4. Okay, so this is, I'm going to go ahead and rewrite it as 2 times the integral from 0 to 2 of negative y squared plus 4, which is going to be 2 times negative y cubed over 3 plus 4y, evaluated from 0 to 2. So this makes life easier, because when I plug in the 0, all that's going to go away. So we have 2 times negative 2 cubed over 3 plus 4 times 2. So 2 times negative 8 over 3 plus 8. So this would be 24 thirds plus 8, negative 8 thirds would be 16 thirds. So we get 32 thirds, which is C. Okay, what is the area bound by the natural log of x over 2 and y equals x minus 8 over 2? So I'm going to graph those in the calculator. So we'll type it in the calculator. Do a standard window. All right, so we can't quite see the intersection here, so we're going to have to adjust. So notice, natural log starts at 0. So I'm just going to go from 0 to, let's go maybe up to 15. And then we go from negative 5 to 5. So we're going to find these intersections. Okay, so the first one's at 11.498. So that is going to be 11.498. Then we'll find the other intersection. So we do the calc intersection again and trace to this one, and we get 0.0373. Okay, so then we'll just set up our integral and use the calculator to evaluate. So it's going to be the integral from 0.0373 to 11.498. The top is going to be the natural log of x over 2 minus x over 8 over 2. You can use the calculator, and the good news is we already have these two equations stored. So I can just do the integral from 0.0373 to 11.498 of y1 minus y2 and we get 21.590. There. All right, then we just have a review question, because as we move through this, we want to keep revisiting past topics. So the integral from 1 to 3 of f prime of x is going to equal f of 3 minus f of 1, which in this chart is going to be 2 minus 4, which would be a negative 2. So that's how we do area using integration.